So in example 2 here, we want to solve this quadratic equation. We could identify if it could be solved by factoring, by calculating the value again of our discriminant. So in our case here, a, of course, is the number in front of x squared, so that's 5. B is the number in front of x, so that's 2. And c is our constant, so that's 7. So our discriminant would be 2 squared minus 4 times 5 times 7. And what you notice is happening here is we have a negative discriminant. 4 minus 140 is negative 136. Well, there is not a real square root of negative 136. Rather, since that is underneath the radical, we're going to find that this is going to be where we're going to get two non-real solutions, because we're going to end up with an I in our solutions. So if we continue on with the rest of our quadratic formula, x equals the opposite of b, which would be negative 2, plus or minus the square root of negative 136, all over 2 times a, which would be 2 times 5 in this case, or 10. Now, this question in my PowerPoint just says determine the nature of the roots. And so what we would say here is that we have two non-real solutions, or it also might be stated we have two complex solutions. One is going to be a plus bi, the other is going to be a minus bi. In this case, we'd say that our solutions are not real or complex. But if we continued on to find what these solutions are, just for practice, then we're going to need to go about simplifying that radical, the 136. So to simplify that radical, 136, the largest perfect square that divides evenly into it, is the number 4. So we can rewrite that radical as the square root of negative 1 times the square root of 4 times the square root of 34. The square root of negative 1, of course, is I. The square root of 4 is 2. So what we now have is x is equal to negative 2 plus or minus 2i all over, 2i square root 34, excuse me, all over 10.
Yeah, I know. It's good to see you too.
And then we know that since everything there is divisible by 2, we should do so. So we have negative 1 plus or minus I root 34 all over 5. Notice our solutions are complex numbers. One is negative 1 plus I root 34 all over 5, and the other is negative 1 minus I root 34 all over 5. So when we answered the original question, determined the nature of the roots, and decided that we had two non-real or two complex, we can see that by continuing on and finding those solutions, we were correct.